Hi, this is George Woodbury from College of the Sequoias in Visalia, California, and in this video I'm going to go over how to solve quadratic equations by extracting square roots. The ideal situation for extracting square roots is whenever you have an equation that contains only a square and constant terms. So one example would be something like this, where I have a squared term equal to a constant. I could multiply out x plus 2 by itself and then subtract 30, but there's a lot more work using that technique than just using the technique I'm about to show you. Another one would be something like this: x plus 7 squared minus 15 equals 34, where we have one squared term and two constant terms. One squared term is ideal for extracting roots, and it could be just as simple as x squared equals 16 as well. When you shouldn't use it is if you have a linear term in your equation, so something like x squared plus 6x equals 30, or x squared plus 8x minus 15 equals 34. Where it's not just a squared variable term, we have a linear term as well. Okay. The technique for solving by extracting square roots: we begin by isolating the squared expression. We'll take the square root of both sides. When we do take the square root of the constant, you do have to account for both the positive and negative square roots. We'll simplify each square root and solve the equation that we're left with. I'm going to walk you through a few examples, beginning with x squared equals 48. Now, in elementary algebra, we may have tried to rewrite this as x squared minus 48 equals 0, but we can't solve this by factoring because x squared minus 48 does not factor. I'll begin by taking the square root of both sides, since the squared term is already isolated. When I take the square root of 48, again, plus or minus, square root of x squared is x, and on this side I'm going to have plus or minus 48 is 16 times 3. I know the square root of 16 is 4. That comes out. The 3 stays in. Now I have two solutions here. So when I write my solution set, it's negative 4 root 3 and positive 4 root 3. Here's another one we couldn't have solved in elementary algebra because the square root of negative 20 we know is an imaginary number, and we hadn't learned about those in elementary algebra. Square root of both sides, because the square is already isolated. The square root of x squared is just x, and on this side 20 is 4 times 5. I know the square root of 4 is 2. Because it was a negative inside the square root, I'm going to also take out an I, and what will be left will be the 5. Negative 2i root 5, comma, 2i root 5. In this example, a couple of things have changed. The expression being squared is a little more complicated, and the squared term isn't isolated. I'll begin by subtracting 5 from both sides of the equation. X plus 3 squared equals 44. Now I can take the square root of both sides. The square root of x plus 3 squared is just going to leave me with x plus 3. On the right side, I'll work with plus or minus root 44. X plus 3 equals 44 is 4 times 11. So I can take out a 2, leave the 11 in the root. And I'm going to finish by subtracting 3 from both sides. When I subtract 3, I'm going to write that negative 3 in front of the plus or minus sign. So I'm left with negative 3 plus or minus 2 square root 11. My two solutions are negative 3 minus 2 root 11 and negative 3 plus 2 root 11. If the radical had disappeared, I would find my two solutions by starting with negative 3 and adding whichever number was here, and then taking negative 3 and subtracting whatever number was there. I'll show you that process here. when we isolate the squared term by adding 30, I get 2x minus 9 squared equals 25. Now that the square is isolated, I'll take the square root of both sides, plus or minus on the right. 2x minus 9 is equal to plus or minus 5, because the square root of 25 is 5. Add the 9 to the other side. 2x equals 9 plus or minus 5, and divide both sides by 2. So my first solution I get by adding 9 plus 5 in the numerator. That's 14 divided by 2, or 7. The second solution I get by subtracting 5 from 9 in the numerator. That's 4 divided by 2, or 2. So my solution set is 2, 7. Right, 1 to go. Again, here I've got a negative constant on the right hand side, so when I take the square root of both sides, I'm going to get an imaginary number on the right hand side, plus or minus square root negative 20. Left side simplifies to be 3x plus 4. On the right side, again, 20 is 4 times 5. That means I can get a 2 out. This is going to be plus or minus 2I root 5. I, because it was the square root of a negative number. I'm going to subtract 4. Negative 4 plus or minus 2I root 5. Oops. I'm going to divide both sides by 3 to isolate x. And when I write out these two solutions, again, I'll do one with the subtraction. Negative 4 minus 2I radical 5 over 3, and negative 4 plus 2I radical 5 over 3. If you have any questions or comments on this video, or if you have a request for a video I can put together on YouTube, you can reach me through the contact page on my website, and that address is georgewoodbury.com. Thanks, good luck.